In this video, we'll talk about existentially quantified statements, and we'll take a look at an example. So in the last video, we looked at universally quantified statements, right? For all x and s, r of x, which meant that exactly that r of x was true for every element of the set S. But there's another way we can take an open sentence and produce a statement from it that's different from universal quantifiers. So again, we'll start with an open sentence. So let's say q of x, an open sentence, over some domain S again. Then instead of saying that q of x is true for every element of S, I can also make the statement that q of x is true just for at least one element of S. And I use the symbol, or I guess I'll write there exists x in S such that q of x is how I would write this. So this is existentially quantified. I'm not saying that q of x is true for every element of S. I'm just saying there's at least one element of S that makes q of x true. So that's another way to say this is there is at least one x in S such that q of x is another way to say this. Now symbolically, we use the symbol, it's this backwards E symbol for there exists there exists, or there is, or for at least one. These are all different ways of saying the same thing. There exists x in S such that q of x is how this is read. And so that, again, that's an existentially quantified statement. Again, for at least one element of S, q of x is true. So let's go ahead and look at an example. This is example 3.6 from the text. Here we have the open sentence q of x, which is x to the fourth plus 2 is equal to 2x squared. So this is an open sentence, and let's see where x is a real number. Then I can make the statement there exists x in R, x is a real number, such that q of x is a existentially quantified statement. Existentially quantified statement. And again, this can be expressed in a couple different ways, right? We can say there exists a real number x such that q of x, or there is at least one real number x such that q of x, or I could say for some real number x, q of x. So lots of different ways I can express this, but again, these are all different ways of expressing this statement that there exists a real number such that q of x is true. Okay, that's it for this video. I know this was a short one, but yeah, think about how existentially quantified statements are different from universally quantified statements. Two different ways of taking an open sentence over some domain and producing a statement about it. All right, that's it.